Okay, so I think there was some confusion surrounding the week 4 assignment on central tendencies, and then also as it went into the week 5 on spread. So I wanted to give a quick video here that would hopefully clarify some things, and Tiffany has wonderfully agreed to let me use her spreadsheet as an example. So let's take a look first of all at what Tiffany was doing. She was looking at all the counties in Pennsylvania and first grabbed the population of each county and then the percent veterans. So what percent of the people living in that county were veterans. Through those two, she was able to then calculate the total veterans. And if you think about it, if we have 101,000 people in the county, Adams County, 11.2% of them are veterans, all we need to do is take 0.112 times this 101 times this population, and that would give us the total number of veterans. Now, because this is it's describing a percent right now, we need to convert that to a decimal first, so that's why she divided by 100, and then she just multiplied it by the population of the county, and that's how she got the total number of veterans in each county. So I think the confusion really started in here on columns E and F. So let me talk a little bit about what these are and what their purpose is. Columns E and F are both ways of describing how far, on average, counties were away from the mean, or I should say away from the center of the data set. So what is that center? Well, we could look at the mean as one way of thinking of the center, and the median is another way of looking at the center. Typically, when we have a symmetric data set, we would probably prefer the mean. If we have skewed towards either direction or have some major outliers, the median is going to work better. But you can see here there's not a lot of difference. About 11% is what the central county average for veterans is. But not every county has that, right? We know, we can look at this list here. Let's take a look at Philadelphia, I'm going to guess is going to be pretty off. Yeah, look at Philadelphia. Only 6% of the people living in Philadelphia are veterans. So much lower than the statewide average. So the question then becomes, so if not everyone is right at the center, how spread out are they? About how far are they away from the center? And there's two ways to look at that. One is taking the absolute value away from a measure of center. And if you do that, you should be using the median. And that's what the whole point of the green cells were, to show you that the median was the best thing to use if you're using this as a measure of spread. So think about, you want a measure of center and a measure of spread. If you choose the median for your measure of center, then the absolute deviations are better for your measure of spread. If you choose the mean as your measure of center, then you want these squared deviations, which will give us the variance and standard deviation. And typically that's what we do. Typically we would calculate the standard deviation. So we would use this measure of spread in column F. But the measure in column E is certainly legitimate also. So just two different ways of looking each county about how far it was away from the center county percentage of veterans. So let's take a look here specifically at Cameron County. Cameron County, we can see, has 15% veterans, so it's pretty high in terms of how many veterans are living there. And the mean there is about 11, so you can see we're about 4 above the mean. So this squared deviation means how far away are we squared. And in this case, we would get, we were 4 away, square that 4, and you get 16 plus a little change. And why do we actually square it here? Well, that gets a little more complicated. One reason is to get rid of the sign so the negatives and positives don't cancel out. That's also the reason we use the absolute value. There's other reasons too, mathematically, why it's nicer if we worked with these squared numbers. But once we get all of these values, so we can see about how far off each county is in two different ways. We can see how far it is away from the center. And then we just add up the totals right here, 81 and 178. Once we get those totals, let's focus now on column F, moving into week 5. What do we really do with that 178? Well, we can tell by looking at any county how far off what their squared deviation was. How far off were they from the mean and then squared. So for example, Cameron was 4 percentage points off. We square that to get the 16. But it'd be nice to know on average how far away from the average were the counties. I know that sounds kind of crazy, but in general, a typical county, what would be a typical value for the squared deviation? What would be, should we be concerned when we're seeing a 7.3? Is that normal? Is that 1.2 normal? Well, it'd be helpful to take an average of all these numbers. So how do we take an average? Well, let me do it over here in this cell. So we have a few different ways. One is we can actually just take an average and grab those right there. So 2.7. So of all these numbers, 2.7 is typically what we're looking at for a squared deviation in this data set. Above that, we're going to be a little more than average. Less than that, we're going to be a little less than average. Another way we could get an average is looking at the sum of all of them divided by the number of counties there were. So the total number of squared deviations divided among the 67 counties would also give us that same value. And this is the same exact value. This is just rounded a little more here down on the bottom. And both of these are the variance. Another way I could get the variance of an entire population here, and what I'm really looking for is the variance of all these values. So notice that also gives me essentially the same, and there's a little bit of rounding there. But all three of these things are called the variation, or the variance. Okay, these are all different ways to get the variance. And what that variance is, it's the average squared deviation for the variable. So the average squared deviation for percent of veterans. But the problem with variation is it's in a unit squared. So we're looking at percent veterans squared. And what is a percentage squared? It doesn't really make sense to us. We can't interpret it. So what we do is we take the square root of that to get back to the normal unit, to get back to percentage, normal percentage instead of percentage squared. So if we take the square root of this value, we get 1.62, and this is what's called our standard deviation. Okay, so these numbers are the variance, 3 different ways to calculate the same thing. This is the standard deviation. We could also take the standard deviation directly of these numbers, but that's what the whole point of column F here was, to calculate this standard deviation to see about how far a typical county would be off of the average. Okay, and to give you a preview of what's coming ahead, what we're going to do is take that standard deviation and we're going to put it around the mean. So our standard deviation there was 1.6. Let me subtract that from the mean. That would give me 9.3, and let me add it to the mean also. That would give me 11.5. If the data is distributed normally, I'm going to get about 2/3 of the data, 2/3 of the county in Pennsylvania will have somewhere between, if I could add, would have somewhere between 9.3 and 12.5% veterans in their county. So 2/3 of the counties. If I go 2 standard deviations away from the mean in both directions, so now I'm going 3.2 down and 3.2 up, that really covers virtually all the counties. So 95% of the counties in Pennsylvania should have somewhere between 7.7% and 14% of their population is made out of veterans. Um, and we'll talk about that more as we get into normal distributions and how we use the standard deviation. But for now, I just wanted to give you a rough idea of what that standard deviation actually was and how the sheet was connected to calculating that. And just to clarify, we won't usually use these columns when we calculate the standard deviation or variance. We'll typically just grab it directly from this column. But I wanted to at least one time give you a picture of where that number is coming from, what's going on beneath the scenes.